On their own, they're not bad. It's when we put them all together that it starts to get a little confusing. But I'm still going to list them out. There's 7 of them, okay? You should be semi-familiar with them now after yesterday, but we're still going to go through them anyway. All right, I'm not going to make you learn the names of them. It's handy to know the names just because then you know you're doing valid properties as you go through. So your book will say name the properties. I'm not going to make you name them, but do make sure you're following the properties as you go, okay? All right, so the first one deals with multiplication. Now the key here is that the bases have to be the same. Okay, if I need to slow down, tell me, because I'm kind of doing a speed racer through this one since y'all did this yesterday. Okay, I just want to make sure you picked up everything you needed to pick up. All right, so when I'm multiplying with the same base, what do I do with the exponents? Add them. So this will be x to the m plus n. If I change it to, let's say, 2 to the 3rd times 2 to the 5th. Again, it's multiply. Don't multiply those bases. Everybody wants to multiply those bases. It doesn't become 4. It's still 2. The base stays, and I still add the exponents. Does that make sense? Okay. Am I going too fast? Okay. The next property. If I take something, let's call it x, and it's already raised to a power, and I raise it again, what do I do with those exponents? Multiply them. So this becomes x to the nm. Okay? Or if it was x to the 3rd, we'll use that same 3 and 5. Then it becomes x to the what? 15. Yes, no, maybe so? Okay. Then we talk about what if, and this one you have to be really careful. If I'm multiplying inside the parentheses, this never, never, never works if you're adding or subtracting in the parentheses. Okay? If I'm adding or subtracting in here, this becomes a FOIL type problem or distribute. But because I'm multiplying here, this exponent can go to both bases in the parentheses. Ben, why don't you put that up? Let's do some math. Yes or no? All right, so along those same lines, if I am dividing in the parentheses, it can also go to both. Yes? What else do we have? Negative exponent. What happens if you have a negative exponent? You have to move it. Think about this as a fraction over 1. You make it positive and you move it. You don't ever want to leave a negative exponent. What about if it starts out in the bottom? You move it to the top. Okay, so wherever it is, make it positive and move it. Does that confuse anybody? What if there was something with it? What if it was 5x squared y to the negative 3? Only the y is what's moving. Okay? Don't move anything else. So this becomes 5x squared over y cubed. What if that negative was hooked to the x? What if it was 5x negative 2 y to the 3rd? What goes to the bottom there? The x squared. Don't move the 5 with it. The 5 is its own piece, okay? So this becomes 5y cubed over x squared. Yeah. Yeah. Is this making sense to everybody? Again, I'm kind of flying through it because I'm assuming y'all watched the video yesterday. Yes? Okay. If I need to slow down, let me know. How about if I have the same base? We talked about if we had the same base and we were multiplying. How about if I have the same base, but I'm dividing? You subtract. You add when you multiply, you subtract when you divide. So this becomes x to the 2nd. Okay. What if this was flipped and it was x cubed over x to the fifth? Negative. Somebody said -2. You're right. But exactly. I don't want to leave it like that. I want to make sure I have positive exponents, so it's 1 over x squared. Last one, and then we'll do several examples before I talk about scientific notation, is 0 exponent. Anything to the 0 power, anything ever except 0 is what? 1. Always and forever. Okay? We good on those 7 properties? All right, let's see if you can apply them. I'm going to, and everybody always says, how do you know what to do first? How do you know which property to use? But there's not an order with this like there is with order of operations when we're simplifying. As long as you're using valid properties as you go and you can justify which property you used, it's fine. And when you get to the point where there are no more properties, then you are done. Somebody tell me something you see that you can do using one of those 7 properties we just talked about. The negative. Somebody said the negative. It goes up. Do we agree? All right. So I've got 2 to the 3rd x squared. Now this x cubed moves up. So
if it's negative, you just move it up?
Yes. If it's negative in the bottom, you make it positive, move it up. If it's negative in the top, you make it positive, move it down. You just change the place where it is. What do you see now? Close. All right, combine the x's. We'll talk about the 2's in just a second. So I've got 2 to the 3rd x to the what? 5th, y to the 5th. Now, somebody said the 2's cancel. Look closely at the 2's and tell me what happens with those 2's. You subtract them. 2 squared. You're exactly right. And anytime you subtract, even if you get a negative number, you keep it in the top. Then you can manipulate it afterwards. So 3 minus 1 is 2. That takes care of those 2's. Now what? Subtract your y's. So I got 2 squared x 5. What's 5 minus 10? -5. Do you see anything else that I could do? I got to flip that negative. I can't have a negative exponent. So I get 2 squared. And if you want to write that as 4, that's fine. And now it's simplified. How do I know I'm done? There's no negatives. I can't combine anything. I don't see anything written more than once. I don't see any properties in this, right? I don't see any properties I can apply, so I know I'm done. Tell me what you think. Did you struggle simplifying them yesterday or no? Good? Really? Good. Good. All right. Let's talk for just a minute then about scientific notation because I feel like that's a struggle sometimes. All right, so scientific notation, and if you watched the video yesterday, it kind of gave you a refresher, or it should have, on what scientific notation was. It's 1 digit, and you can only have 1 digit. And then you do the decimal, and you do everything else that follows it, times 10, and this exponent on the 10 tells you which way you would move the decimal, right? Positive means move it right. Negative means move it left. So we're not really focused as much on scientific notation and expanding or condensing that down. What I do want to talk about are operations with scientific notation, specifically multiplication and division, okay? Because scientific notation is a multiplication problem. Do you agree? Yes? Okay. So what if I took, let's see. What if I did 1.2 times 10 to the 5th, and I want to multiply that by 2.7 times 10 to the negative 12. We're going to multiply those two things together. Well, if you think about, this is just a big multiplication problem, and multiplication is commutative, yes?
Yeah.
So I can multiply the numbers in front. Do you agree with that?
Yeah.
What's 1.2 times 2.7? I don't know.
5.4.
3, what is it? 3.24? Ben's just blurting out a number up there.
5.4.
And then I can add the exponents. That's pretty easy, right? Let's make it a little bit harder then.
Yeah.
You can have the negative on the 10. That's the exception to the rule because it's telling you, right. What if I had 7.35 times 10 to the second times 9.28 times 10 to the 25? All right, multiply the numbers first, right? What's 7.35 times 9.28? What is it? And then add the exponents, right? Now, is that in scientific notation? Not quite. Why is it not in scientific notation? Exactly. Good job. Did you remember that from yesterday, or did you just know that?
Yeah, we did good.
Okay, so when you have to adjust, it gets a little confusing. If I adjust to the left, I'm going to add to that exponent. If I adjust to the right, I'm going to subtract from that exponent. So it's kind of the backwards of what you think, because instead of expanding the number, I'm kind of condensing the number down. Okay, so if I need, and I'll write you a little note on here, to adjust, left, you add, right, you subtract. Can it only be left? We're not doing significant digits. Is that what you're talking about? Yeah. No. All right, 28.
What was Caroline?
She had to be, let's do a division.
This wall teacher.
Okay.
I'm not a huge fan of Miss Walls.
Don't talk about my college. All right. This one's actually off your homework. So
He got you, bro.
5.5 times 10 to the negative 8. All right, so now I'm dividing. So do the same thing. What's 1.1 divided by 5.5? 0.2.
6 times 10.
Subtract negative 3 minus negative 8 would give me what?
That'll give you 5.
5. Positive 5. Negative 3 minus negative 8.
Oh.
1.1 divided by 5.5, which would be 11 over 55, which is 1/5, which is 0.2. Whoa, use your calculator. Move it to the right one. So do I need to add or subtract? Subtract. You subtract when you're dividing. Negative 3 minus negative 8. All right.